Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Firdaus bin Muhammad Sulaiman from M3CS24568. So I will be presenting my final year project for CSP 650 entitled Web Application Firewall or WAF using Modsecurity and Openlitespeed cache as reverse proxy. So what is web server? Web server is source of information which contains valuable assets for companies and businesses and made up the internet. As we all know, it contains web pages, images, videos, and many more. It also being hosted on machine. As pandemic arises, citizens of Malaysia are required to stay at home. If they want to go outside to buy necessities or goods, they are required to follow certain rules and guidelines. To make it easier for the consumers, the company and businesses have taken the opportunity to operate virtually. So, all the customers need are to visit the company's or business's website and purchase it virtually. They can have their goods being delivered to their home without going physically to the store. There is main concern for web servers which leads to this project. It is subjected to malicious attacks such as DDoS, SQL injections, cross-site scripting, and many more. Researchers has come up with two solutions in order to counter these pertaining issues. First, Intrusion Detection System (IDS), and second, the Intrusion Prevention System (IPS). IDS only detects the malicious content within the packet when it is entering the network, while IPS not only that it detects but it also prevents the packet from entering the network. Then it comes to the development of the third generation firewall, which is Web Application Firewall. Web Application Firewall able to operate or perform the features of IDS and IPS, while also able to know where the attack comes from and log it for future references. And it is important for network administrator to secure the network from these pertaining issues. What seems to be the problem with the Web Application Firewall? First, it is a financial burden. According to Larry Ponemon, chairman and founder of Ponemon Institute, organizations are dealing with significant annual costs linked to ownership and staffing of Web Application Firewall. For example, we have a Cloudflare Web Application Firewall Security. It is a cloud-based web application firewall service provider which does not have their customers to install the web application firewall locally, but instead they can use the cloud service in order to have their web application or web server secured. In order for the Cloudflare to maintain these services, they are required to spend a lot of money to maintain their servers for the web application firewall service, and end up having their customers and consumers to spend a lot of money for the subscription cost. Next is the web application is exposed to the internet. Attackers can retrieve critical information they need in order to perform those attacks, which is the web server's IP address easily, especially if the web server is bare naked in the internet. This means that the client or the users are able to connect to the web application directly without any intervention from any security measures. Although if they have a security features installed on the or embedded inside the web application, the IP address is exposed to the client or the users. There are three objectives for this project. First, to design a low-cost web application firewall or WAF service using open sources. I am using Modsecurity for the web application firewall and Openlitespeed's web server for the reverse proxy. Second, to implement reverse proxy solution to enhance the security of web application. And lastly, to develop web application firewall with combined open source WAF set of rules. I am using OWASP CRS or OWASP Core Rule Set and Komodo Rule Set. There are three scopes for this project. First, it is of course a web security project. Second, it is for protecting the application layer, which is the seventh layer of the network layer. And lastly, it is a web security strategy for small company or organizations. There are two parties that gain significance from this project. First is the company itself, as it able to have a low-cost web application firewall deployment, which have a reliable security, less technical work in long term, and also it has a reverse proxy. The second party is the user, which have trusted and secured experience while surfing the company's web, and the web loads faster. We'll be looking to the conceptual diagram of this project, which shows generally how does this project operates. There are three components: first, user; second, web application firewall and reverse proxy; and lastly, the web server or the web application. For the user, there are two kinds of users: first, legitimate user; second, attacker. An attacker is also user with malicious intent. So both type of users will be sending HTTP requests to the web application. The first section of the web application firewall or the reverse proxy is the Modsecurity. So Modsecurity will be referring to the configuration files which contains the rule set as mentioned before, which is the OAuth CRS and the Komodo rule set. From these rules stated in the configuration files, Modsecurity will be filtering out and monitoring the HTTP requests from the client. For the users, as there are no malicious intent or content within the packet, the request will be passed to the next section, while for the attacker, as the request sent is purposely or intended to exploit the web application, the web application firewall will respond with error 403, means that the web server understood the request but refused to respond. So the next section is the cache. The reverse proxy will be using cache features as well. For the request, HTTP request from the legitimate user will be passed to the next to this section. So in case there are multiple of users requesting for the same page in the same amount of time, instead of the reverse proxy requesting the same page from the web application, the reverse proxy can use a cache page and respond and send it to the user. So this will leave a load from the web application or the web server, the actual web server. Lastly is for this project I am using DVWA or then vulnerable web application, which is a web application purposely made for penetration testing. There are a lot of vulnerabilities that can be tested on this web application. Okay, this is Modsecurity. Modsecurity is an open source web-based firewall application or WAF supported by web server, Apache, Nginx, Lightspeed, and IIS. Modsecurity install servers will carry out 80% of attacks over the web application level. So the features of web Modsecurity is first, security monitoring and access control, virtual patching, full HTTP traffic logging, security assessment, web application hardening, passive security assessment, simple request or regular expression based filtering, URL encoding validation, auditing, IP reputation, null byte attack prevention, server identity masking, and lastly approach memory limits. For the web server, for the reverse proxy, this project I am using Openlitespeed instead of Nginx or Apache. So from the figure shown below, we can see that there are three types of experiment conducted by the Chemi Cloud. First is the response time in milliseconds. The lower is better, which we can see Lightspeed is better than all of the rest. Second is the request per second. The higher is better, so Lightspeed has the best score in this category. And lastly, the transfer rate KB per second, higher is better. Lightspeed has the highest transfer rate among all other web servers. Lightspeed is actually an enterprise version of web server, while Openlitespeed is the free version or the open source. So in this project, I am using Openlitespeed for the best performance comparison compared to the rest of the web server. This is the Modsecurity detailed process or the flowchart on how does the Modsecurity operates. But for summary, we'll be looking at the next one. These are the Modsecurity phases that will be discussed on how does the Modsecurity works. There are 5 phases in the flowchart. The first phase is the request header. So in the request header phase, the HTTP request header sent by the user to the web server will be inspected for any malicious pattern before the web server starts to process the user data. If there is, the request body will signal to buffer. The second phase is the request body. By this phase, all of the user's request has been retrieved by the web server. The third phase is the response header. By this time, the web server starts to send all the requested data request by the user. And the fourth phase is the response body. By this phase is if the request body has been signaled to buffer, the response body will start to send any error message such as authentication failed and etc. if needed. And the last phase is the logging phase, where all the rules that we used in the process it will be logged in a log file for future reference. This is the Openlitespeed cache process flow check. So the cache page will be checked whether it has been expired or not. If no, the cache is served to the user. If yes, is the background preparing previous page request? If yes, then they will ask, does the expired cache object pass the cache stage H? If no, expired cache object is served to the user. If yes, the request is sent to the backend to generate a new page. Same also works if the background is not preparing for the previous page request. It will also trigger for the backend to generate a new page. So what does this mean is that the page cache on the reverse proxy will be used to serve to the user if it has not been expired. However, if it has been expired, the reverse proxy will request for a new page from the actual web application or the backend. Okay, so now we'll be looking at the demonstration of an attack towards this project. So the attack that will be executed is XSS reflected attack or cross-site scripting reflected attack. On the left side, we have the reverse proxy 192.168.168.128, while on the right side, we have the actual web application 192.168.168.129. Okay, so the attack will be executed via the URL browser, and the attack will be telling the web server to display this particular message, which is "Hello John." Okay, however, the reverse proxy has the web application firewall configured, and based from the HTTP request, the web application firewall detects there are invalid requests and against one of these rules, and therefore it responds with error code 403, which means that the web server understood the request but refused to respond. Now we'll be execute the attack on the actual web application. Since the actual web application does not have any sort of security measures, so the SSS attack is successful on the actual web application. There you go, it shows the message "Hello John." This means that there are no security measures able to mitigate the attacks, and the web server process the user's request. From the demonstration that we see just now, the SSS attack or the cross-site scripting attack on the reverse proxy has been unsuccessful, and it shows the error code 403, which means that the web server understood the request but refused to respond. However, the SSS attack on the web application firewall has been successful because it has no such security measures, and it shows the message "Hello John" as intended by the attack. This is the demonstration to show that the cache features of the reverse proxy does works. So first we enter the developer mode on Chrome and we disable the cache locally. So this means that if the page does respond with a cache, it is a cache from the web server itself, not from our machine. So this is the first time that we visit the about page of the web application on the reverse proxy. We can see on the bottom right corner, the Lightspeed cache is a miss. This means that the page that we see from the figure is directly retrieved from the actual web application. This is the second time that the about page has been loaded, and as we can see from the bottom right corner, Lightspeed cache hit private. This does means that instead of the reverse proxy retrieve the page from the web application, the page that has been sent to the user is the cache page that has been cached from the previous request. This is the result of the summary of the attack executed on the web application and the reverse proxy. So the attacks that have been executed are first the SSS attack, which is the cross-site scripting, second the HTTP smuggling, and lastly the SQL injection. all of the attacks has been successfully executed on the web application without the WAF. This means that the page has been fully exploited by the attacks. However, the attacks fail when being executed on the reverse proxy with the web application firewall. This shows that the web application firewall does work properly in the reverse proxy. This is the result of the Go Test WAF scan. As mentioned before, this project uses hybrid approach when configuring the rules for the web application firewall. So the hybrid approach means that it is a combination of Commodore rule set and OWASP core rule set. This test is aimed objectively to show that the hybrid approach is the best option compared to use only one of the rule set. The attacks that have been executed on this test on this scan are local file intrusion (LFI), mail injection, XML external entity injection. When the web application firewall on the reverse proxy is being configured to use only Commodore, the local file intrusion attack is failed. This means that the Commodore are able to mitigate the LFI attacks. However, for the mail injection, XML external entity injection are successful when being executed on the reverse proxy with Commodore rule set being configured. Next, when the OWASP being configured on the web application firewall within the reverse proxy, the local file intrusion shows that the attacks have failed. This means that some of the attacks pass while the other attacks has been blocked. So, this shows that the OWASP are not fully capable of mitigating the LFI attack. However, for the mail injection and XML external entity injection are fully mitigated and failed when being executed on the reverse proxy with OWASP being configured on the web application firewall. And lastly, of course, the hybrid. All the attacks executed on the web application firewall within the reverse proxy are failed due to the combination of rules of Commodore and OWASP. This shows that the hybrid is the best approach to secure the network with the proper rule set. We have arrived to the conclusion. The project mainly uses open source product with good security protection as it uses two sets of rules which are products from different security solution organizations while not exposing its actual web application to the public by using reverse proxy. This project also allows for the company to only update its web application firewall in order to cut costs of updating each of their web application. Not only that, it also allows for future scalability with ease. There is no limitation to self-improvisation of the product. The company able to tweak the project to suit its preferences. Overall, it is an affordable solution with great security protection for web applications. The objectives are achieved. That's all from me. Thank you.